Hello everybody, my name is Jeffrey, and in this tutorial we will start working on lighting. Well, lighting can be calculated many different ways, but we are going by the Phong shading model. Phong shading model basically means you have three types of lighting. You have ambient lighting, which is the base light that's always there. So imagine you're in your room. Room is closed, you have the curtains closed and no lights turned on, but somehow you can still see all of the objects in your room. That's because there's some base lighting. We call this lighting ambient lighting. So that's ambient lighting. Next, diffuse lighting. Well, each object has in each object in your room, if you have the lights turned on, will be brighter or less bright depending on how much the surface is facing the light. So an object of which the surface is facing the light will be well, the brightest, and the surface which is not facing the light at all will be the least bright of all the surfaces. So basically we're going to calculate that brightness by using the dot product between the normal factor and the directional factor of the light. And the final type of lighting, which we won't be using, but you can use it if you really want to, just look it up on the internet, but we won't be using it because we won't be. But that's specular lighting, and that's basically if the light from the light source directly reflects into the camera. But we are not going to be using that type of lighting. Let's start in our mesh class, or mesh class, model class. What am I saying? Okay. First, we're going to create a private method. Private void calculate normals and calc normals. And we're going to take in a vertex array and vertices and a integer array indices. The normal vectors are the vectors which are pointing out of the surface of the object. Once more. So, how are we going to calculate these normals? Well, we're going to loop through all the indices. So, for int I equals 0, I is less than indices.length, and then I plus equals 3. Because we need to calculate the lighting on the surface, so we need the we'll loop through each triangle, and each triangle has 3 indices, so yeah, that's why. So int I0, that's the first index, is indices sub I. Int I1 is indices sub I plus 1. Amazing. Int I2, well, you might have already guessed it, is indices sub I plus 2. Yes. Okay, then we need to calculate the two vectors which are coming from the first vertex vector. No, vertex. Yes, I'm getting my names all mixed up, but we are going to calculate the lines along the two side lines of the triangle coming from the first vertex, and then we're going to calculate the vector which is standing on top of that by using the cross product. And we're going to apply that vector, which we then get as a result from the cross product, as the normal vector for all the 3 of the vertices. And if a vertex is used in more than one triangle, it will also automatically take the we will make it so that it automatically takes the average between those by normalizing those vertices. Yes. I hope it was clear. So yeah. So let's first calculate the vector normal, the vertex normal. Yeah. So vector 3f f vertex vector 1 equals vertices sub I1 dot get position dot subtract. So now we're calculating the vector from one vector to another, so between two vertices, and vertices sub I0 dot get position. And we're going to copy this line of code and do this the same for the second one, and also make sure to import your vector 3f class. It's important. Next thing. Oh, my Eclipse closed. Oh, that's odd. Well, workspace. Let's wait for it to load and hope that it saved our code. If it didn't, I'll restart this tutorial, but it looks like it didn't save my code. That's too bad. Let's see, model. Oh, yeah, it did save our code. So, okay. Let's go on. Vector 3f normal equals vertex 1 dot cross. So we'll take the cross product of between vertex 1 and vertex 2 and normalize it. If you don't know what the cross product is, take your right hand, point your index finger forward, your thumb upward, and move your middle finger to the left. Point your middle finger to the left. So, and the cross product. Your middle finger is the cross product between your index finger and your thumb right now. So, yeah, that's just think of it like that, and it'll make sense. And then we're going to apply this normal. So vertices sub I0 dot set normal, and we're going to set it equal to vertices sub I0 dot get normal dot add normal, and then copy this. Only 3 times, and change this to 1 and a 2, and also over here. And we haven't added normals to our vertices yet, so private vector 3f normal, and we'll increase the size to 6, and we'll take in a vector 3f normal, and over here vector 3f normal, comma normal, and over here type this dot normal equals normal, and we'll generate some getters and setters for this. So okay, get normal. So, and now we need to take the average of all the normals which are added up to each other and calculate the average. So for int I equals 0, I is less than vertices dot length I plus plus, and vertices sub I dot set. Now this method of calculating normals does not work really good for models which have a low amount of vertices, but it will work for objects with a higher amount of vertices. So yeah, but this is basic lighting, and yeah, we'll need it when we are rendering our world later. So set normal to equal to vertices sub I dot get normal dot normalized. Yes, that's it. Oh, and we'll need to change this a bit. Boolean calculate normals, and we're going to create a second method for this, for the ones that are lazy like me. Vertex array vertices int array indices, so that we don't have to calculate normals by default. C's and false. So by default, if someone doesn't specify the boolean, they won't get the normals calculated, which is fine, I guess. And over here, if calc normals, then calc normals using the vertices and the indices. So, why do we have an error? Comma null. Yes. Well, null new vector 3f. If you type null in there, we will get a null pointer exception, and that is not something we do want. So, and one final thing, when we buffer the vertices, we have to type true at the end of here, because we do want our normals calculated. Yes. So that's that. Entity renderer. Oh, in here we'll have to enable another vertex attribute array. So paste that over here. Up. Vertex attribute array 1. And this is important, change this to a 1. This can still be 3, but here offset it by 12, because 3 times 4 equals 12. It's easy like that. And a final thing, we have to actually buffer the normals. So where's that get normal? There. And that buffers them. Now we'll have to actually calculate it. How many times do I? Oh, I'm 3 minutes over. Well, this is a longer tutorial from now on. This tutorial will be it will take about 5 more minutes. So layout location equals 1, and we're going 1. We're going to take in a vector 3 normal, and this time we're going to send out to the fragment shader what the normal was. So out vector 3 normal and add a 0 after it. Then normal 0 equals normal, and in our fragment shader we're going to take in vector 3 normal, and we'll create a constant, also constant float value ambient light equals 0.1. This will be here for now, and we'll also create a uniform. So uniform vector 3 sun. This will, for now, this will be the sunlight. Yes. So go over here, go over to your shader class, basic shader, and add the uniform. So add uniform sun, and then over here, public void update sun vector vector 3f sun set uniform sun equal to sun of sun. What's next? Oh, one important thing is to when you output this, you need to actually apply the world matrix to this. So vector 4 normal, and this time be sure to make this 0.0 so that we don't apply any translation, so moving around to this vertex, and we'll do this, so world matrix times this. And now here's the thing which is very neat about GLSL. You can just type .x, y, z and it will only output the x, y and z component. But where were we? Oh yeah, basic shader. Final thing is to update the sun. Yes, update the sun. So basic shader dot update sun new vector 3f and 0,1, 0, and save it. Oh, and import the vector 3f. I hope this works. So let's run. Oh, we didn't do anything, but that doesn't matter. Sun. Why doesn't that work? Basic shader, sun. I have saved it. Oh, yes. We'll actually have to do things with the uniform, otherwise it will give us an error. So float in no brightness equals max between ambient light or the dot product between the normal 0 and the sun, and then multiply this by the brightness, so brightness times this, and this should work. So let's run. And as you can see over here, there's shadow on the bottom. Let's move them in. So subtract 500 from the C value should do the trick. No. Well, let's not do that then. Comment this out. Entities that add new entity, new vector 3f 0, 0, 5, comma comma model. So, and there is your cube, but then with shadow over it. And as you can see, the shadow isn't very accurate because the sun is coming from here, and this face is, well, pointing more than pointing downwards, but you get the point, and it does kind of work. So let's just be happy that it does work like this. When we're going to render worlds and everything, and tiles and voxels and everything, we will make sure to make a more, well, accurate lighting engine. But yeah, for now this is fine. Yes, I will let you believe that this is fine. So that was it for this tutorial. Let me see what are we going to do in the next tutorial. In the next tutorial we are going to handle input, which is fun. So I see you in the next one. Bye.